Hey everybody, Dr. Darrell here. Last thing we're going to do for this lesson is practice a problem with some pulleys. So I highly recommend that you try this example problem out first before you watch the solution, just to see if you are getting the getting it right. So see if I can get this loaded. Here we go. Okay, so here is the problem. We have a load Q. Why would that happen? Zoom my share here. Okay. Whew. We have a load Q right here applied to pulley C, and pulley C can roll on the cable ACB. So first thing to note, we have cable ACB that does this. This is all one cable. It's going to follow those rules for pulleys that we studied in the previous two videos. And then there is a second cable, CAD, that goes around this pulley and supports the load P. Here is that load P. We know that P is equal to 750 newtons. We want to know the tension in ACB, the magnitude of the load Q, and we're going to draw some free body diagrams for pulley A and pulley C. So I've established my knowns and unknowns. The big thing here is that my unknowns is we're looking for the tension in cable ACB and then the magnitude of Q. We're going to start by drawing free body diagrams. So I will draw two free body diagrams. The first one is the free body diagram of pulley C. And then I'm also going to draw a free body diagram for pulley A. Again, I highly recommend you try these without watching the video, just so you can see if you are grasping the material, and then you can come right back here and see if you got it right. So here is pulley C. And let's look at all those places again where it interacts with something else. So we know it's going to have the force Q. It has this cable in two spots, and then it also has this cable, right? Okay, so we are going to have the tension in ACB, and that's going to show up actually in two different spots on each side. But because it's all one rope, it's going to be the same magnitude. And we have P, and then we have Q. To make this free body diagram complete, I'm going to include in here my angles. So these are both 55 degrees. They're parallel to each other. Okay, so there is the free body diagram of pulley C. Now I'm going to draw the free body diagram of pulley A. Again, try this on your own first before you come and watch this video. So pulley A has this tension holding it up. So I'm going to call this the force of A. It has a force coming down of P, which is equal to 750 newtons. And then it has this force going to the side, and that is also P because of our rule of forces. Okay. So, and then again, to be complete, we can write in this angle here is 55 degrees. So that's 55 degrees, which would mean that this up here is 55 degrees. All right, so let's solve some of these free body diagrams. We are going to look at the free body diagram of pulley C and write our equations of equilibrium for pulley C. And we're going to do that. We have two equations available for us. So we will write first the sum of the forces in the x equal to 0. What acts in the x? I have negative TACB times the cosine 55, which is this force. Then I have minus 750 cosine 55, which is this force. And then I have plus T ACB times the cosine 25, which is this last force. And then I can solve this to find TACB times the cosine of 25 minus the cosine of 55 is equal to 750 cosine 55. I'm going to solve this and find that the magnitude of TACB is equal to 1292.88 newtons. I'm going to go ahead and round that up and say that it's 1293 newtons. Okay, so I've already found the first part of the unknowns, which is the tension in the cable ACB. And now I need to find the magnitude of Q, and I can find that by summing the forces in the Y and setting them equal to 0 for that same free body diagram. What acts in the Y? We have negative Q plus 750 sine 55 plus TACB, which we know from our previous one, times sine 55 plus sine 25. So I can solve for Q equal to 750 sine 55 plus 1292.88. I'm going to keep it in its not rounded format when I am using it in another calculation, times sine 55 plus sine 25, and I get the magnitude of Q. It's 2219.8 newtons. I'm going to round that up to 2220 newtons. So there you go. I was able to do this just by solving the free body diagram of pulley C, although you kind of use the free body diagram of pulley A and understanding of pulleys to get that 750 newtons for P acting on pulley C. I hope this was helpful and that you were able to solve it on your own, or at least try before watching this. And I will see you all soon.